All right, this lecture is on the use of simulation as a form of virtual reality, to create virtual reality. That term was new 10 years ago, and now everybody knows what it is. Virtual reality means creating a 3D world that you wrap around somebody, and sometimes you do it with head-mounted displays. Sometimes you do it by putting them in an igloo kind of simulator. Sometimes you put them inside of a vehicle shell, and all they can see is the shell and the screens. But it essentially means doing something to immerse people into the virtual world you're creating for them. Something to cut them off from the room and the tables and the desks that are really there, and show them the dirt and the grime and the smoke and the vehicles and maybe a factory that you want them to think is there and want them to react to. That's what simulation for virtual reality is. And we're going to begin this lecture with a really excellent videotape on the Battle of 73 Easting. It's 8 minutes long, and the Battle of 73 Easting was fought during Desert Storm. During Desert Storm, one of our cavalry regiments, I believe, came upon an Iraqi division and decimated them. After they decimated them, we sent out data collectors to gather information about the position of every vehicle, what it was doing, who killed who, and then how we moved up and attacked them and then destroyed another level. After we collected that information, we loaded it into a simulator and replayed it back for these guys in a simulation environment. And we had the crews who were actually there sit and watch the simulation and tweak it until they said, no, I was a little farther forward. No, when he blew up, there wasn't any smoke. When that one blew up, that's the one where the whole turret just shot off of the tank and went spinning through the air, et cetera, until the simulation played out, until the guys who actually were there said that's what it was like. And that opened a lot of doors in people's minds about what can you do with simulation. And we're going to show that videotape now.
Roger, I'll go and go to the 3 tanks, 1 truck over. I got, I think 4 tanks and 1 MTLD, something like that. I want those 2 ones, they're talking about it. Roger, I heard the contact and he said, citizen sections, any sections, this is 1-3. He said, it's like, I was lying down. Have you sent them on grid yet? Over. I got a center mass 723.
Eagle Troop first made contact with the enemy on the afternoon of 26th of February. We received heavy machine gun fire from a village. I ordered the 2 tank platoons to come online abreast of my tank, and we fired a volley of high explosive anti-tank rounds. When the tank rounds impacted into the village, large holes, almost the size of the entire wall itself of the cinder block building, were blown into the buildings. My role in the creation of this battle began in the desert, and I was met in the desert by a research team.
They came to us not months after, but hours after the action actually took place, so it's fresh in our mind.
We walked and drove the path of Eagle's assault from the beginning when we first fired onto the village until our consolidation point.
We spent the next couple of months painstakingly going through all of this evidence, some of which was clear, some of which was murky, trying to plot out exactly what happened.
Topped the ridgeline, saw the entire panoply of the enemy, killed 3 of their tanks in less than 10 seconds.
The interesting thing about what happened in the G Troops area is that I had 3 separate battles going at the same time.
My troop hit a dug-in force oriented roughly in our direction. Tanks and personnel carriers. The first volleys of fire were fired by the scouts who were out front.
And right now, tow launchers came up across the board as soon as that thing went up, and that thing burned. That was one of those infamous volcano deals. Okay. That was about the most intense time right there.
Okay.
When those first things went off, and me waiting on those tanks getting up there.
So probably no more than 6 minutes until you start seeing tanks near you.
Less than that. Not that long. 5. I'm thinking 4 to 5.
So I was overwhelmed with the amount of work and the painstaking detail that went into recreate this battle.
This power of manipulation allows you to move in the 3 dimensions, with the 4th dimension being time. Basically jumping ahead or behind in time as well as in space, so going anywhere that one wants to.
Change the weather, we can change the Iraqi tactics, we can give them weapons they didn't have, we can give ourselves future weapons that we would like to have.
It was at that point when I saw the initial success of our first volley fire that I ordered the troop to continue to the assault.
And he said, go tanks lead. We had it where the tanks were in a V-shaped wedge. And my scout platoon went from going from lead back behind the tanks,
providing what we call scratching fires, and covering the rear of the tanks and eliminating pockets of infantry.
We tried to refight the battle as closely as possible to what our data told us the real battle was like.
It allows me to view from my perspective, from what I've seen in the battle, and to try to make it as accurate as we can recreate it.
That's true. I mean, it looked like you're looking out at your tank at the same desert.
We weren't getting anything out of some of these berms until one of my scouts shot a berm with a tow missile, and then the berm exploded.
I received a call at that point that we had reached our limit of advance.
They wanted us to stop, right in the middle of it.
I said, we can't stop. It was evident that we had surprised the enemy and had seized the initiative from him.
That was not the first time that I fought a battle. I was able to fight battles at the National Training Center. I have taken platoons down these tank tables, CALFEXs, simulations, and we've also got on the ground. But if you use the training realistically, then my first battle is fought in a simulator or on a range versus a battlefield like Iraq.
You look back at what you did, and you see nothing but burning vehicles, and it's a feeling that it's deep inside that you know you've done your job.
During the battle, there was no time to feel any emotion. There was no time to feel any fear. I found myself as I watched this battle, just I could feel the adrenaline flowing. I could feel my palms start to sweat.
I was surprised and delighted to hear comments from several of the participants in the battle. That's exactly what it was like.
If you sit behind a tank night sight and you look out of the thermals, it's just like looking out of a tank.
It can take and test ideas against a set measure. So we can measure the delta. An officer says, I can do better than that. I say, step up, son, do better than that.
It's group training at the combat level that we never had before.
We can test future ideas, concepts, tactics, doctrine, and vehicles, because we now have a benchmark that's rooted in ground truth.
So we're looking at a possibility that can really change our understanding of war.
But it also is making me feel good that we weren't forgotten. I wish I could bring my whole platoon in here and show them, say, here, sit here, watch this, because this is what we've done.
It's better than film, because film footage you can't change. This, they can. It'll probably be the most accurately recorded battle in history.
We've been moving most of the day through a sandstorm.
That was the Battle of 73 Easting, the capturing of it in virtual reality. And there are other videotapes where they showed this same exercise on the Senate floor and had the senators go through it and see what they were able to do. And in this tape and in one of the other tapes, you get a real sense for people's brains starting to function. People starting to say, you know what we can do? We can, and thinking of new ideas on how to use simulation that they never thought of before. That's really impressive. You see them not just thinking, well, I can train people to do virtual simulation, but I can train them to do something else as well. So we're about to embark on virtual simulation. That's kind of what we're doing with it right now. The technology you saw was old technology. The simulators that were representing that, that's old stuff. But there's so much more we can learn in how to apply it that doesn't require better graphics or better terrain databases. Sorry. But there's so many things that we don't understand on how to use this. That's what we need to learn, in addition to improving the technology of the visuals and the sound and the terrain, that kind of thing. All right, we're going to step back almost 100 years. We're going to step back to 1910. Shortly after the Wright brothers invented their first airplane, people started inventing airplane trainers. You don't want to necessarily be like one of the Wright brothers, to be launched into air and go, how do you fly this thing? Wait a minute, what do I do? And so one of the things that they would do was build an actual airplane airframe and set it on a little gimbal. And it would set on the gimbal and you would point it into the wind. And as the wind blew over the control surfaces, the whole airplane would respond to your controls, somewhat like it would respond to a real aircraft. And so people would learn how to operate in this new three-dimensional world sitting on top of this little 3-foot gimbal in a real aircraft, minus the engine and a few other pieces. But after they experimented with the Billings trainer, they went on to the Antoinette trainer. And the people building the Antoinette trainer said, wait a minute, it doesn't matter what the device looks like. It doesn't matter that its wings are the right length and that the tail is in the right place. What matters is that it maneuvers correctly. So they took away all of the looking right things and concentrated on getting it to feel right, to respond correctly. And the control surfaces on this device are in different places, and it doesn't look like an aircraft, but it feels more like an aircraft when you fly it. It's still stimulated by the wind blowing over the control surfaces. Guess what the next step would be then? Linder and Heidelberg said this wind thing is really difficult. If you live in some place like Florida where the wind never blows, it's really tough to practice flying. So they put a motor in theirs and attached a propeller on it. You turn it on and the propeller pushes air backwards over the control surfaces and you create your own wind. They essentially built a wind tunnel onto the front of their simulator. And so you could practice with this device with or without wind. In buildings, in Florida, places where the wind doesn't blow. The other thing that they did is they attached this simulator to a little scooter. And so the wind pressure controlled the control surfaces, but it also pulled them around in a field as they practiced flying. That's some of the early flight simulators. That's where they were learning lessons about, does it matter what the device looks like, or does it matter what it feels like, back around the turn of the century.